h's so that you can divide this h out. All right? Any questions about that? Okay, so we've been looking at function composition for a while, and now we're going to do function decomposition. Anyone think they know what that means? Yeah, so like when we get these expressions, when we plug in other algebraic expressions into them, we get more complicated ones. So now we have the more complicated expression, and we're trying to break it down into simpler ones. Before we do that, let's just do one more recall of composition of functions. So go ahead and find f of g of x and g of f of x, if these are your two functions.
Damn.
Let's put 2 minutes on the clock. The same thing as I told you to do here is what you're doing.
What? Yo.
Sometimes you just leave it like you can't really complicate it.
Leave it as is.
Let's move to simplify. Another 25 seconds. Yeah. This one's just like okay. Eyes up here. So let's do f of g of x first. What is f of g of x? 2 square root x plus 2.
Close it, and then just
Right. And because that's a radical, we can't do anything. We don't distribute a 2 inside. We don't even distribute a 2 to the 1 because that's not inside the parentheses. This is where we stop. Okay. Sure.
Would it be like square root 2x plus 1 and plus 2?
Yep, square root of 2x plus 1 and then plus 2. This one we can simplify just a little bit more. So this would be 2x plus 3. Okay, so we combine like terms here.
That's it.
Alright, so what I'm going to do now is show you a function, h of x. Now, what we do know is that h of x is f of g of x. It is a composition. We want to figure out what f of x and g of x are going to be that would produce this function. So take 1 minute to turn and talk with the people around you about what you think f of x and g of x could be.
X
Go.
plus 3 squared. I don't know.
Randy's giving suggestions to his group. off in 3, 2, 1, 0. So, any thoughts about what f of x and g of x could be in this function? Okay. G of x could be x squared minus 9. What made you think that g of x was x squared minus 9? This is louder.
They're in the parentheses.
Yes, right? So like, when we did g of f of x, notice that f of x was in parentheses, and f of g of x, we used parentheses. So it's kind of like looking for parentheses here to figure out what your g of x is in this case. All right, if g of x is x squared minus 9, what would f of x have to be in order to get this to be a composition? 1 over x plus 1. So that's our conjecture. I want you to do f of g of x and see if it's equal to h of x. Take 1 minute. We've made a conjecture, now let's validate it. Do f of g of x and see if it gives you back h of x.
But this window kind of feel better. It's more windows. Anything else seems to go.
Okay, well then, like, we gotta pick a stroke, right? Okay, does f of g of x bring us back to our h of x from the problem?
Yeah.
Yes, because this x squared minus 9 is going to go in for this x down here. And that's exactly what h of x was. Okay, so here is basically a step-by-step kind of thing here. We want to look for parentheses. So I was really correct there when she was saying, like, we're looking at parentheses, like that tells you that something was plugged in, right? We use parentheses when we plug something in. So that has to be your g of x. And then if you pull that out, whatever's left is your outside function. What I like to do sometimes is when I make a guess for g of x, I like to cross it out. Wherever it was. And notice that this reads 1 over, because I crossed it out, x plus 1. And that's exactly what I have here for f of x. And that's exactly what you guys told me. So crossing out whatever you say is your inside function, your g of x, it can help you read what f of x should be better. Any questions about that?
So basically, which one is like the opposite?
Mm-hmm. Yeah, we're taking them apart, yeah. Alright, you guys are going to try one now on your own. Let's take 2 minutes here. Figure out what f of x and g of x are. If you get done early, do this verification process that we did to figure out if you did it correct. 2 minutes starting now at lecture. Carl's already gotten started. Remember to think of g of x as your inside function. I saw a couple of really cool things on people's papers. But right, can you share with me your f of x and g of x?
F of x is the square of x, square root of x, and g of x is equal to x cubed plus 7.
Okay. Why did you choose to make f of x and g of x that? Okay, why does it make sense? Let's try to help him out with his reasoning. Yeah.
So when you plug in just g of x into f of x, you'll get the result of beta.
Right. Like if we identify this as the inside function, then I can just cross this out, right? If g of x is x cubed plus 7, then all I'm left with is the square root of x. But Elias, you had something else on yours that was similar, and I said I didn't disagree. What was it?
G of x is x cubed, I think that's what you said. And then f of x is the square root of x plus 7.
This was the less popular answer, but I actually like this answer a lot because it also works, right? What made you do that?
Well, you could just plug in x cubed into the, where, substitute it in for x, and you'll still get the result of h. It's just,
Yeah. So by Elias just making just this part is g of x, and you can cross it out, and what you're left with is the square root of x plus 7. So you mean that there's more than one way to rewrite these things?
Yeah.
Yeah. So this is really, really cool in the fact that there is no one way for us to do it. It's up to us to how we want to define our two functions. But both of these were very, very valid. Any questions here about that? Now I know we didn't have parentheses in this example like how we did the other ones, but think of g of x as your inside function. Those of us that were still a little bit confused, g of x is your inside function. So whatever function you can read that is inside something, whether that is a radical, whether that is in parentheses, whether that's a denominator, okay? All of those things are inside of something. And you can always make those functions your g of x, and then whatever's left is your outside function, your f of x. Any questions about that? All right, let's move on to example 3. Y is equal to x squared minus 4x plus 5 cubed. Go ahead and work on that in 2 minutes. Again, if you get done early, make sure to